Hi, if you're watching this video, you're probably taking Dr. Zoval's Chem 108 class. Today we're going to assume that you have a basic understanding of a few things. One, the periodic table, that you know what elements are and that you have an understanding of what a hydrocarbon is. We also are going to assume that you know what the octet rule is and what a covalent bond is. We are going to, as a review, go over a few definitions. First definition is hydrocarbon. An organic compound that contains only carbon and hydrogen atoms. Number 2, covalent bond, a bond in which two atoms share a pair of valence electrons. And 3, the octet rule. Atoms gain, lose, or share valence electrons in order to have 8 valence electrons. Today we are posing this question to you. What are 3 ways to write hexane? The first way we're going to talk about is a line bond structure. In hexane we have 6 carbons. The carbons need to have 4 covalent bonds, and it needs to fulfill the octet rule. In order to fulfill the octet rule, which again is to share or lose or gain electrons, we're going to show the sharing of these electrons by drawing a line. And in a line bond structure, it needs to show the bonds to the hydrocarbons. In the hydrocarbon, which as a reminder is an organic compound that contains only carbon and hydrogens, we need to show those carbon and hydrogens with the lines representing the covalent bonds. Carbons must have 4 covalent bonds to each carbon. So in the line bond structure, you see all of those bonds. Here for carbon 1, you can see the 4 covalent bonds or the sharing of the valence electrons. There's 2, 4, 6, 8, which fulfills the octet rule. In the condensed structure formula, we have the same 6 carbons as we did in the line bond structure, but the covalent bond between the carbons is not drawn, it's assumed. We do draw, however, the hydrogens in a condensed way. We don't show the lines, we just show the number of hydrogens, that are going to it. So here on the end, you can notice that there are 3 hydrogens. And the reason there are 3 on the end is because you need to fulfill the octet rule. The hydrogens on the middle are only 2 because, for example, on this carbon number 2, it's covalently bonded to the carbons next to it. So there's 1 and there's 1, which is 2. So you need 2 more to fulfill the octet rule of 8 valence electrons going to that 1 carbon. In the skeletal structure, we are going to assume a few things. 1, we're going to assume that at each end of the line, there's 1 carbon. So in the skeletal structure, as we draw out, we're going to still have 6 carbons, but as we draw it, we assume there's 1 here, there's number 2, number 3, 4, 5, 6 carbons in this hexane skeletal structure. At the end, we don't show the hydrogens, the 3 hydrogens. On the skeletal structure, hydrogens are left out. So you can assume at the end that there are 3 hydrogens, 2 hydrogens on these 3 carbons, and on this end there are 3 hydrogens. Even though they're not shown, they're assumed. The skeletal structure is probably the fastest, easiest way for those in the industry to draw the skeletal structure. I'm going to talk for just a minute about a way that maybe you can remember as you're going day to day and as you're studying, for your big test that you have coming up. An easy way to remember the line bond structure, we're going to use phones as an example. If you had, back in the day, a phone in your house, it was called a landline, and it had to be connected to the wall. And just like that, the line bond structure has to have the lines drawn to show the covalent bonds. And as technology advanced, the phone was didn't have to be connected to the wall. It could be taken in the car as a car phone, and it didn't have those lines that had to be connected to the wall. It was in the condensed form. So we'll use the first cell phone as showing the condensed form. It was still really big and bulky, but it didn't have those lines that needed to be required to be plugged into the wall. The skeletal structure we're going to use as the modern day iPhone 5 that is thin, sleek, convenient, quick, on the go. You can access a lot more things. And the skeletal structure just allows you to write the same information in a very fast, quick way. So we have talked about 3 different ways that we can write hexane. Again, it's line bond structure, condensed structure formula, and skeletal structure. And this shows the hydrocarbons drawn fulfilling the octet rule and showing in different ways the covalent bonds.